What we're going to talk about now is the two-stage completion methods, and we'll start by talking about the one that does the AND variant of the two-stage completion methods. And that's a situation where a completion stage dependent action is triggered when both of two previous stages complete. So you can think of that as kind of merging. And we're going to talk about the then combine method. There's a couple other ones, but they're all sort of variants of the same idea. So then combine. You can see then combine. Then combine takes a by function, and it's going to apply this by function to the results of two previous stages. And you'll see in a second how it's used to do this. So you can think of this as a logical conjunction, right? Something gets run only when both of previous things complete. And it returns a completable future containing the result of the action which is applied after both previous stages complete. So you can think about then combine as essentially performing a very limited form of a reduction. You're reducing two things to one thing. And we typically use this to join two paths of asynchronous execution. And you'll actually get a chance to practice this in assignment number 4. But I'll give you a simple example here just to illustrate the basic idea. This is in my EX8 folder in the GitHub account. So we're going to create two completable futures, comp F1 and comp F2. And they are going to go ahead and asynchronously invoke operations. So this one's going to, say, multiply two big fractions. This is going to divide two big fractions. I'm just coming up with something for it to do, not the world's most profound example. And then what we're going to do is when comp F1 is complete and comp F2 is complete, when both of those things are complete, then we're going to go ahead and add the results of those two asynchronous computations. So then combines action, which in this case is add, is triggered when both the other completable futures are done. So when we get done asynchronously multiplying two big fractions and asynchronously dividing two big fractions, then we go ahead and add the results together, and then we print them out or something. So we use then except just to print the results out. Obviously, then except doesn't get called back until then combine is finished, and then combine doesn't get called until both of its comp F1 and comp F2 completable futures are done. OK, so that's an example of an AND.